All right, everyone, we've got our 7.3 notes today, and we're introducing our trig ratios by starting with tangent. Okay, tangent is the first trigonometry ratio and concept that we're going to talk about. Okay, so in order to, what trig functions can do, trig ratios, they allow us to find the angle measures and side lengths of our right triangles. So in order to use them, we have to be able to identify what sides are opposite and adjacent to our angles, and then what the hypotenuse is. So we know the hypotenuse of our triangle is always opposite of our right angle. And for tangent, for this ratio, we don't use hypotenuse at all. What we use is we use the side opposite to an angle and the side adjacent to an angle. So as we look at angle A, the side that would be opposite to angle A would be this side BC out here. So to answer this first one, the side opposite is side BC. It's always the opposite side will always be the other two letters. So if we notice angle A, side opposite will always be BC. The side adjacent to angle A, there's two sides that touch angle A, our hypotenuse here, and then this other leg, which is the leg that we're going to use for this ratio. Side AB is adjacent to angle A. It shares a letter, it touches that angle, and it's not the hypotenuse. So side opposite always is the other two letters. Side adjacent shares a letter. So as we look at this next example, fill in the blank, side PQ is what to angle R? PQ, angle R, doesn't share a letter at all, is not the hypotenuse of our triangle, so PQ is opposite to angle R. Versus QR, which touches our angle R here, so it is adjacent to angle R. And then the third question, QR is blank to angle P. QR here doesn't have angle P, doesn't share a letter there, so it is opposite of angle P. Okay, so make sure, if you have questions on that at all, make sure you write them down, you count as annotations, and you can ask them of me the next day in class. A ratio of the lengths of two sides in a right triangle is called a trig ratio. So we're always comparing two sides, and again, it allows us to find either angle measures or side lengths. The ratio of the lengths of the legs in a right triangle is called the tangent of the angle. So tangent uses just the legs, it doesn't use the hypotenuse at all. The other trig ratios that we'll talk about, cosine and sine, they will use the hypotenuse. Okay, but the tangent ratio is whatever angle we're finding the tangent of. So in this one, if we're finding the tangent of angle A, then we will use the leg opposite that angle. So the leg opposite of angle A would be BC, and we'll put that over the leg adjacent to A, AC. So tangent is always opposite over adjacent. Opposite over adjacent. So if we wanted to, on this one, if we wanted to find the tangent of angle B, then we would do side AC, that leg opposite, over side BC, the leg adjacent. So we'll look at some more examples, put it into practice, and it'll make a little more sense as we keep going. So if we want to find the tangent of S, we want to write each answer as a fraction and as a decimal rounded to 4 places. Make sure you pay attention to what the directions ask you to do so that you answer the whole question. So if we want to find the tangent of S, then we need to do the opposite side of S. RT is the side opposite of S, over the side adjacent to S, ST. Again, we're not going to use our hypotenuse at all on this one because it's tangent. So we put RT over ST, and then we can plug in the lengths that we know. We know that RT is 80 and ST is 18. We always want to reduce our fraction if we can. We can divide both of these by 2, and we get 40 over 9. So we have the tangent of S equals 40 over 9. Can't reduce that further, but we can turn it into a decimal and maybe need to round it. If we're going to round it, we round to 4 decimal places. So I'm going to open up my calculator here and do 40 divided by 9. equals, and I get 4.4444 repeating. Tells me to round it to 4 decimal places, so I'm going to write my answer there as 4.4444. And there is my tangent of s, written as a simplified fraction. Always simplify your fraction, and as a decimal rounded to 4 places. So I'm going to do the same thing, but do it for angle R. So the tangent of R would be the opposite side, which is going to be side ST, over the adjacent side, RT. ST is 18, RT is 80. What you'll notice here is that the tangent of S is the reciprocal of the tangent of R within a triangle. Okay, so then we have, we already know how to reduce it. Tangent of R reduced is going to be 9 over 40. And then we're going to turn that into a decimal as well and round it if we need to. 9 divided by 40 equals 0.225. I don't need to round it at all, so I can write it as equals 0.225. There is tangent of R. So all we're doing here is we're setting up a ratio of the sides, opposite over adjacent, and then we're reducing that fraction if we need to, and turning it into a decimal to find the tangent of an angle. Okay, so next example, same type of problem. Tangent of K is going to be equal to the side opposite over the side adjacent. So if we're looking at angle K, the side opposite is LJ here. So we have LJ over KL, which is the side adjacent. And again, we're not using the hypotenuse at all because it's tangent. LJ is 15 and KL is 8. So we're going to put 15 over 8. So tangent of K is equal to 15 over 8. And then if I turn that into a decimal, it is 15 divided by 8, which is 1.875. 1.875. Okay, so there's my tangent of K, angle K. And I'm going to go ahead and find the tangent of angle J as well. Tan J is going to be the opposite side, KL, over the adjacent side, LJ. Again, it's just going to be the reciprocal of tangent of K here. So that's going to be 8 over 15. Tangent of J then is equal to 8 over 15. And we turn that into a decimal. 8 divided by 15 equals 0.5333 repeating. So we're going to round that 0.5333. 4 decimal places. There's my tangent of J. Okay, so here's my tangent of K and J, and that's with the 3 side lengths given. We can set up a ratio and find the tangent of our angle. Okay, example 3 and 4 are going to work a little bit different. I'm going to pause the video here and do these last 3 examples in a different video. All right, this is part 2 of our 7.3 day 1 notes. So the first thing I'm going to start by doing is labeling my vertices so that I can name my angles and sides a little bit easier. Okay, then we're still going to use tangent, and we're going to set it up with the information they gave us. So they gave me information about angle C, so I'm going to set up the tangent of C is equal to its opposite side over its adjacent side. Opposite side being AB, adjacent side being BC. And then I'm going to plug in what I know. So tangent of C, I know that C is 56. So I'm going to have the tangent of 56 equals x over 13. That's what A, B, and B, C were. And then there's a couple different ways that you can input this into your calculators to solve it, but I'll explain it as though I'm inputting it into an iPhone calculator, since I'm going to assume that's what most of you have. And then if you need help inputting into your calculators, make sure that you ask me in class so I can show you depending on what calculator you have. So you'll need access to a scientific calculator. You can get that on Google. You can just type in scientific calculator, it'll give you access, or you can use a phone and turn it sideways, or you can use a scientific calculator if you have it. So how I would encourage you to solve this problem here and to input it into your calculator. So first thing I'm going to do here is I'm going to get x all by itself. by multiplying both sides by 13. So x divided by 13, if I want to get rid of the 13, I'm going to multiply. That's going to give me x equals 13 times the tangent of 56. Okay, so then to input this into an iPhone calculator, the first thing you want to make sure is you want to make sure that it doesn't say rad on your screen, because if it does, that means that it's measuring the angles in radians, but these angles are being measured in degrees. So just make sure it doesn't say rad. If it does, press the little button that says DEG, and that'll change it to degrees. And then what we're going to do is we're going to input the tangent of 56 first. So on an iPhone calculator, you're going to put in 56, and then you're just going to press the button that says tangent. And on many scientific calculators, it'll be that same input, 56 tangent. On some scientific calculators, like if you use Google to find a calculator, then you'll put in tangent first and then push 56. Okay, but regardless, when you put in that tangent of 56, you should get a decimal that's something like 1.482569, etc. Okay, so if we were to round it, which I don't want you to round it because it will make it more accurate if we don't round it, but we're going to get something like 4.8256. Okay, so that's what tangent 56 is in degrees. If you put it in tangent, if you put in 56 press tangent, you get a negative decimal, then your calculator's in radians. Okay, but don't round it. Okay, I want you to just put in 56, press tangent, and you'll have this big old long decimal. And then all you're going to do from there is you're going to press times 13 equals. So we put in, here's our input in our calculators. Okay, 56, then tangent, then times, then 13, then equals. So put that in exactly into your iPhone calculator if you have an iPhone calculator. And you should get 19.2733. And that's where I want you to round it. If you round it earlier, you're going to get a different answer. This is more accurate. So if you put in 56 tangent times 13 equals, you will get a decimal that is 19.273, and if we rounded to that fourth decimal place, it would be 3. Okay, so again, if you round it at a different point, you're going to get a slightly different answer, but you should get something that's around 19. And if you need help inputting into your calculator, check the video that I will upload about using the Google calculator. And then you can also ask me in class the next day. And I'll go over this with you guys in class as well, with the inputting feature. Okay, but hopefully we can figure out how to set up that equation and solve it at the very least. Okay, let's try example 4. I know inputting into our calculators will give us a little bit of trouble. So again, we'll go over that in class some more, but let's make sure that we can set up and solve these equations. So again, we're going to use tangent. We're going to have tangent of 61 degrees is equal to opposite over adjacent. So I jumped a couple steps there. Tangent of angle E, which is the one they gave me, would be equal to the opposite side, which is DF, the other two letters, over the adjacent side, ED. Not EF, because EF is the hypotenuse. So we're not going to use it for tangent at all. Okay, then I plugged in E was 61 degrees, DF is 22, and ED is X. Okay, now again, this is like a proportion. So we can also set this up and solve it like a proportion. So it'd be tangent 61 over 1 equals 22 over X. We can cross multiply. That's going to give us X times tangent of 61 equals 22. And then if we want to solve for X there, we're going to divide both sides by tan 61. Tangent of 61. It's going to give us X equals 22 divided by the tangent of 61. And then again, this is going to be a little tricky to input. So let's go ahead and for this one, we can round it earlier. So in your calculator, input 61, press tangent, and that's going to give you a decimal that will be about, we'll go to 4 decimal places, 1.8040. That's tangent of 61 approximately. And then we'll go ahead and do 22 divided by 1.8040 equals, and so x will be approximately equal to 12.1951. And for this unit, we're going to stick to rounding to 4 decimal places unless it tells us otherwise. Okay, so again, depending on when you round, you could get a slightly different answer. If you don't get an answer even close to 12, then you inputted your data incorrectly, and you need to check with me tomorrow in class. Or you can keep toying around with the input to see if you can figure out how to get that 12.195. All right, last example, example 5. Example 5, same type of problem. We're going to set up a tangent. I'm going to go ahead and label my sides. Let's do RST. My angles there, not my sides. So I'm going to have the tangent of the angle that they gave me information about was T is equal to the side opposite over the side adjacent. Then I'm going to plug in what I know. I know that T is 40 degrees. I know that SR is H. And I know that RT is 20. Then if I want to get H all by itself, I'm going to multiply both sides by 20. That cancels out my 20s on the right side, and I've got H equals 20 times tangent of 40. And then I'm going to input that on my calculator as 40, then press tangent, then press times 20 equals, and the height of my lamppost is approximately 16.7820 feet. Again, that input on my calculator is 40 tangent times 20 equals, and I get 16.78199, which rounds to 16.7820. And then we have units on our problem, so there should be units on our answer. All right, that's it for these examples. That's it for these notes. Tangent is the first trig function we're introducing, so make sure you have listened to these notes and not just watched them. Make sure you write down questions and extra comments as you have them, and make sure you ask me in class the next day and as we go over the notes. See you tomorrow.